Examining distributions for one quantitative variable. Recall that quantitative variables are variables that are numerical values. However, not only they are numerical, the arithmetic of those numbers makes sense as well. Consider this example. The following data represent the number of employees at various restaurants in a city. These values vary depending on the restaurant. Use the data to construct a histogram U10 to 19 at the first interval. But first, we will construct a dot plot and a stem plot for this distribution, and then we'll go back to the histogram. There are 22 values in this variable. To construct a dot plot, we will put a bunch of dots that represents each numerical value on the number line. But before we do that, we need to observe the data a little bit more. We need to know the smallest values in the dataset and the largest values in the dataset. It looks like the smallest value is 15 and the largest value in the dataset is 42. We first draw a horizontal number line and we need to label the smallest number, in this case 15. It is okay to start with number that is lower than the smallest number. So for example, it is okay to start with 10 or 11 and so on, or even with 0. Although we don't want to start with 0 because that would waste too much space. Once we start with number 15, the next number should be 16 on the number line, even though 16 is not on the list. And then the next number should be 17, equally spaced between any two consecutive numbers. And then 18. And we keep doing this until we get to the largest number on the number line. Now, again, this is the help line only. It is the number line only. For the dot spot, we would put a dot for each of the values in the data sets. So for example, the first value is 22. So we find 22 on the number line and we put a dot above that number line. The next value is 35. So we put one dot above 35. This should have the equal height at the previous dot, and the dot should have the same size. The next number is 15. The next one is 26. The next one is 40. The next one is 28. And then 18. And then 20. 25, 34, 39, 42, 24, 22. There is a dot on 22 already. We would need to put another dot above the first dot. And so 22 had two dots stacked up vertically. Next, 19, 27, 22, another 22. So there should be 22, three dots stacked up vertically. 34, there are two 34s stacked up vertically. 40, there are two 40s now. 20, there are two 20s now. 38, and then 28. This is what we call the dot plot. It is one of the graphical displays of the quantitative variable. For the stem plot, for each of the value, we will split it into stem and leaf. So for the value 22, we will split this into two. The digits in the unit place will be the leaves, and the digits in the 10 place will be the stem. This is what is called the stem plot. We will have a line that separates the stem and the leaf. On the left is the stem, and on the right is the leaves. But observe that the smallest number is 15 and the largest number is 42. That means the stems consist of values from 1 to 4. And so we start with 1 and we cannot skip. 1, we start with 1. We need to go to the next stem. 2, whether 2 is a stem in the data set or not, we have to include it. 3, 4, we cannot skip. The first value is 22. We would find the stem 20 and then put the 2 in the leaf. The next value is 35. We would find the stem 3 and put 5 in the leaves. And then the next one is 15. We put 5 in the stem 1. The next one is 26. The next one is 40. So we put a 0 in the leaves. The next one is 28. Equally spaced here. 18, 20, 25, 34, 39, 42, 24, 22, 19, 27, 22, 34, 40, 20, 38, and 28. In most cases, the leaves need to be in increasing order. And so we're going to fix this. The stems are consecutive digits 1, 2, 3, 4. For the leaves, for the stem 1, 5, 8, 9 already in increasing order. For the stem 2, there are 2 zeros for 2 values 20. And then there are 3 22, so there should be 3 leaves value 2, and then 24, and then 25, 26, 27, and then there are 2 28. They are now in increasing order. For the stem 3, we have 2 34, so there should be 2 4, and then 35, 38, 39. For the stem 4, we have 40 and then 42. This is what we call the stem plot. If any of these leaves are too long, we might have to split the stem into 2. But if we split the stem into 2, we have to split every other stem into 2. So for example, if we see that the leaves for the stem 2 is too long, we will need to split 1 to 2. So we would write 1, 1, 2, 2, 3, 3, 4, 4. So now there should be 2 stems, 1 in the split stem. We would put the value between 0 and 4 in the first stem 1, and we would put values, the leaves, between 5 and 9 in the second stem 1. Similarly, there are now 2 stem 2. We would put the leaf value between 0 and 4 in the first stem 2 and 5 to 9 in the second stem 2, and so on. Moving on, we will now construct the histogram. To construct the histogram, we will first make the frequency table and the relative distribution of the variable. We listed the value down here again for convenience. Now, there are 22 values, so we can't just list all 22 values for the table. Instead, we will organize them into bins. It is up to us to consider the bin size, but we were told to use 10 to 19 at the first interval. And so we will have to do so because the interval was specified already. The first bin consists of numbers from 10 to 19. We would use the notation open bracket 10, comma 20, close with a parenthesis. When we use the brackets, the number 10 is inclusive. When we use the parenthesis, the number 20 is excluded. And so that is why this interval consists of value from 10 to 19 only. And then we pick up 20 to 30. The bins should have the same size here. And so 10 to 20, 20 to 30. So the next one is 30 to 40. And the next one would be 40 to 50. Recall that even though the largest number was 42, but we would have to use 40, 50 in this case. And then we would place these values into each bin. And so for 22, we will put it in the second bin. For 35, we will put it in the third bin. For 15, we will put it in the first bin, and so on. 26 there. What we're doing is that we tally this up. 28 would go there. 18 go there. 20 falls into the second bin. 25, 34, 39, 42, 24, 22, 19, 27, 22, 34, 40, 20, 38, 28. And those are the tallies only. We keep track of them, but now we would have to count them. There are 3 in the first bin, there are 11 in the second bin, there are 5 in the third bin, and there are 3 in the last bin. Let's see. 3 plus 11 plus 5 plus 3, 14 plus 8 is 22. That's correct because we have 22 values. Then we would compute the percentage. Now the corresponding percentage will be the count over the total multiplied 100%. The count over the total multiplied 100%, and so on. We see that for the first bin, we have about 13.6%. For the second bin, we have 50%. For the third bin, we have about 22.7%. And for the last bin, we have 13.6%. Now, the total should add up equal to 100%. And if we don't get 100% precisely, then that is still okay if it's up by 0.01 or even 0.1%. And so if we have 6 plus 6, that is 12, plus 7, that's 19. So the total in this case is 99.9%, which is still okay because of the round-off error. But this number should be very close to 100%. Now that we have the bins, the counts, or the percentages, we can construct a histogram. For the histogram, we first draw the axis, and we label the bins in the horizontal axis. And so these are the values. The first one is from 10 to 20. This is the first bin. The second bin is 20 to 30, and the next bin is 30 to 40, and the next bin is 40 to 50. We will draw the bars that has the height using this count, and so the largest number of count is 11, so we might use 5 and then 10 and then 15. For the first bin, we have 3 counts, and so the height should be approximately this. For the second bin, the height is 11 counts, a little bit more than 10. each of these bars should have the same width. The next one has 5 counts, and then the next one has 3 counts. This is what a histogram looks like. The histogram should have no gap in between unless the bin has 0 count. And we should label the histogram. And so the vertical axis are the count, and the horizontal axis will be the values, in this case the number of employees. Notice that if we were to present the histogram, we do not have these raw data. And so if we need to use one number to represent the first bin, for example, then we would need to use the average of the two. And so if we were only given this picture, meaning we do not have this raw data, and if we need to use one number to represent this first bin, then we would have to use number 15 because 15 is the average of 10 and 20. Similarly, the number that represents the second bin would be 25, and then 35, and then 45.